Viewers, today we are going to see how the rainbow is formed. We have seen already the sunlight consists of all the visible spectrum. Also it includes ultraviolet and infrared. So as far as the rainbow is concerned, we are interested only in the visible spectrum. So the sunlight is directed towards the raindrop. You all know that when rains, the atmosphere is covered with raindrops, small raindrops. So the sunlight is passing through the raindrop. So now we have to see what happens. Basically, the basic condition for forming a rainbow is the sun should be shining at the one end and rain should be happening in the other end. Okay, so we have raindrops at the other end. So if an observer want to see the raindrop, his back should be facing the sun. So observer back should be facing the sun. Then only he can visualize the rainbow. Now in terms of optics, we will see what are the things that is happening within the raindrop. So the sunlight, we know that all the frequencies or wavelength right from 400 nanometers, so 700 or 720 nanometer, that is VGR. So the white light, so sunlight is nothing but the white light which contains all these wavelength. And I already told you within this 400 nanometer to 700 or 720 nanometer, all the wavelength, infinite wavelength you can imagine. And we said that it is all shades of the particular color. Now what happens is the sunlight falls here. So the raindrop is assumed to be spherical in shape. So what happens is, first step, it undergoes diffraction. So assume red wavelength. So it undergoes diffraction. It touches here and reflects back. So there is something called critical angle. So critical angle means if a ray enters here and passes through the another medium, okay, it goes like this because of two different refractive indices. Now what happens is you keep on increasing this angle. At one particular point, this ray will fall exactly in this axis. That is the interface between medium 1 and medium 2. This angle is called critical angle. If you further increase the angle, what will happen is you will get reflection. That's the idea. So therefore, the red wavelength after touching this undergoes a reflection. So reflection means the angle is greater than the critical angle. That's why it is getting reflected back. And once again, so here, from here it goes diffraction, then refraction, then here it is reflection, and once again it is refraction. Similarly, this spectrum contains, so this is violet, this is red. So from violet to red, you have all the visual frequencies or wavelength. So now violet goes here. So violet also undergoes refraction. Then it goes total internal reflection, comes back here, and once again refraction. So this is how a rainbow is formed. So when a viewer is viewing, suppose the viewer is standing here and his back is facing the sunlight. When he views in this direction, you can see all the wavelength that is happening within the raindrop. So the shades will be, all the wavelengths will be seen here. Now one important point is the critical angle of this said raindrop is 48 degree. That's why I told you what is critical angle. Critical angle is the angle at which the waves gets bent and falls exactly at the interface between medium 1 and medium 2. So the angle between the incoming sunlight and the violet is found to be 40 degree, this angle. And the angle between the red wavelength, the incoming sunlight and the red wavelength is 42 degree. And I already told you the critical angle, which is 48 degree. That is, these three angles you should remember. Okay, and what are the things happening in this refraction? Then reflection, and once again refraction. So that's how a rainbow is formed. Now we have considered only one raindrop. If you have n number of raindrops, you can see the complete at each and every particle you can see the complete rainbow over a very large distances. Okay. So what happens between 2 raindrops or 3 raindrops? What happens to multiple reflections within the raindrops? All these things we will see in the next video. Hope you have understood this topic. Thanks for watching. Nandri.